First, we are asked to create a table of values and continue the pattern. This can be helpful for creating a linear relation or a graph. We can begin by filling in the number of flowers in our table of values. We can see that one flower will cost $7, two flowers will cost $10, and three flowers will cost $13. As each flower is added, the price is increasing by $3. We can use this pattern to continue and complete our table of values. 4 flowers will cost $16 and 5 flowers will cost $19. Finally, we will try to create a linear relation. As each flower is added, the price is increasing by $3. That means 3 will be our coefficient, and it is dependent on the number of flowers. This needs to equal our price in dollars. However, one flower needs to equal $7, not 3. In order for the price to be $7, we need to add $4. If I have one flower, 3 multiplied by 1 is 3, plus 4 is 7. If I have 2 flowers, 3 multiplied by 2 is 6, plus 4 is $10. By using substitution, I can see that my linear relation is working. Next, we will look at the cost of renting a bicycle. The cost of renting a bicycle is $5 plus $2 for every hour the bicycle is rented. We are asked to create a table of values to show the cost of renting a bicycle from 1 to 3 hours. Let's begin by putting in the numbers from 1 to 3 into our table of values. The cost of renting a bicycle for 1 hour is $5 plus 2 for that first hour, bringing the total to 7. If we want to rent the bicycle for an additional hour, we will need to add $2 more and another $2 for the third hour. Since the cost is increasing by $2 for every hour, I know that 2 is my coefficient and it's dependent on the number of hours the bicycle is rented, but I cannot leave out my flat fee of $5. All of that together will give me my cost. How can I write this in words? The cost of renting a bicycle is double the number of hours plus 5. Finally, we will look at an example that starts with a linear relation. Here we see 10 plus 7n equals c. We can begin by filling in the numbers from 1 to 3 into our table of values. We will find the value of c by using substitution. If n is 1, what will c equal? According to the order of operations, we must complete our multiplication first, and finally our addition. If n is 1, c is 17. Next, let's substitute in 2 for n. Again, we must complete our multiplication first. If n is 2, c is 24. Finally, we will substitute 3 for n. Again, completing the multiplication first. If n is 3, c is 31. What real-life situation could be represented by this linear relation? Here we will see two examples. First, Joel charges $10 to shovel a driveway, plus $7 for every hour it takes to complete the shoveling. An additional example of a real-life situation